The Tagsurance label counting and inspection system is developed for production quality inspection and further quality analysis. This solution provides high-definition measurements with higher sample amounts than ever before. The RFID performance is measured by a Voyantic Tagsurance UHF tester integrated inside the machine. Tagsurance uses the Class 1 Gen 2 protocol and is capable of measuring the threshold power levels for tag responses on defined frequencies, or even a complete threshold sweep as seen now on the screen. In high-speed testing, the tag is tested on multiple frequency power combinations called test points. For RFID quality verification, it is important to test the tag performance on multiple frequencies. Testing outside the reader frequencies enables catching the detuned tag responses. In this case, the failed sample is failing only the communication test on 995 MHz, but passing the tests on typical reader frequencies. The green curve on the graph represents the typical tag response for the tested label. The test points are set according to the label specifications and typical production variation. The tags with a response outside these criteria fail the test. The red curve is the actual response of the tag that failed the test. When a tag with a different response is used in an end application and detuned by surrounding materials, it performs differently than the tag specifications would imply. The tags can be tested on a reel by using near-field coupling. Unlike the typical inductive loop antennas, the Voyantic Snoop Pro near-field coupling element generates a dominating electric field. For labels with dipole antennas, the near-field results achieved with the Snoop Pro have an excellent correlation to actual far-field performance. Triggering from the exact label to be measured assures that each label is tested even if some labels are missing from the roll. It also minimizes the error of possible variation in the label pitch. The accurate and repeatable alignment of the tag to the antenna is critical when testing in near field. The sophisticated PLC control of the Tagsurance enables high precision speed control and ensures repeatable alignment. The Tagsurance PLC has a touchscreen interface where the machine parameters are adjusted and the run mode is selected and started. The built-in logic detects missing labels and counts the failed tags, showing both counts on the screen. The PLC records not only the amount, but also the locations of the missing and failed labels on the roll. If you're currently analyzing manually dozens of tags per production lot with a wide frequency threshold sweep, imagine how many tags could be analyzed in the same time, completely automatically on the reel. The sweep takes 2 seconds per tag. Additionally, the tag memory can be read for traceability. All the information is recorded in a log file for later analysis. Comprehensive quality analysis is important, especially in new process development, analysis of reclamations, subcontractor and customer support, and so on. The threshold power can be measured on defined frequencies, making the analysis much faster than the complete threshold sweep, but providing still enough data for statistical analysis. Here the tags are tested on 3 different frequencies, and the threshold power of each sample is recorded in the graph in time domain. The threshold levels on a single frequency can be measured also in continuous movement. In addition to the threshold power levels in time domain, there is a histogram drawn to present the variation within the overall sample. The software calculates the average threshold power and the standard deviation of the tested samples. For each frequency, the control limits can be set so that if they are exceeded, the tag fails. The software calculates the percentage of samples exceeding the defined limits. The current test is run at 60 meters per minute. The maximum speed is dependent on tag antenna size and pitch. This label has a 23 mm wide antenna and the pitch is as narrow as 30 mm. We are now testing 533 tags per minute. We are still receiving measurement data on the threshold power, and we are able to see the variance of the samples. We have 3000 tags on the roll, and the analysis for the complete roll takes less than 6 minutes. We are now verifying the tag response on 3 frequency power combinations carefully chosen to screen out any detuned tags. Each test point takes 5 milliseconds, so the overall test sequence ran here takes only 15 milliseconds. Even with the relatively wide tag antenna of 23 mm and narrow pitch of 30 mm, we are able to reach a speed of 28 meters per minute. This results in 933 tags per minute. So testing this whole roll of 3000 tags takes only a bit more than 3 minutes. The Snoop Pro shielding plate is attached with magnets and is easily exchanged according to the tag size. The optimal plate opening size is defined based on the tag antenna size and pitch. The antenna location is adjustable for different sizes of labels on different liner widths. The trigger sensor location is changed with an adjustment knob on the antenna assembly. Fine-tuning of the alignment needs to be done carefully, but the good control makes it easy. As you have seen, the RealSurance label counting and inspection system is a turnkey solution for offline RFID label quality assurance. It can verify the label performance across a wide frequency band. The unique Snoop Pro coupling element and carefully implemented adjustments make this machine easy to operate and flexible for different label sizes and materials.